going to assume by this point that you have a basic understanding of how to factor greatest common factors and trinomials at this point, and we're going to look at how to simplify a rational expression, meaning I have some sort of fraction here that hopefully can be kind of picked apart and simplified. So what we're going to do here is we're going to talk about how to simplify these things, and then not all tests or classes will make you do this, but we'll talk about also some excluded variables or excluded values for the variables that we're talking about. Just in case you see that terminology or that notation come up, you'll understand what it means. So we'll start off here with this 4x plus 16 on the top. What we're going to do with these, the idea is going to be to completely factor the top and the bottom and then cancel any matching factors. So the top here, I don't see much that I can take out other than a GCF of 4. So I'm going to take the 4 out. So that'll be 4 over x plus 4 if I do that. So if I divide each of these by 4, that'll leave me with 4 times the quantity x plus 4. You can distribute that back in to check my answer, make sure that works. On the bottom here, this should factor into, hopefully, 2 parentheses here. We're going to have an x and an x. And since this last sign is minus, that means my signs need to alternate, so I should have a plus and a minus. And now I need to think of some factors of 36 that are going to add to give me that negative 5 in the middle. And it looks like, if I try, I get 36 and 1, that's not going to work. If I try, what about 9 and 4? So if we do 9 times 4, and I make the 9 the negative one, because I need a negative times a positive here. Let's make the 9 the negative one. That should add to give us a minus 5 in the middle. So if we do minus 9 and plus 4, that should get us where we need to go. Now the top is completely factored and the bottom's completely factored. Only at this point am I allowed to cancel. You're not allowed to go at the original step and say, oh, I see an x here and I can cancel those x's. You have to make sure that it's completely factored before you try to start canceling things out. So at this point I see x plus 4's they have in common. I can cross out the x plus 4's on the top and the bottom, and then I am left with 4 over x minus 9. Now, there's one other thing I'm going to add in here, so I'm going to leave a little space. I'm going to add some exclusion for the variables. Basically, what is x not allowed to be? So, in this case, if we look at the bottom here, we've got our x minus 9 and our x plus 4. If I were to plug, for example, a negative 4 into here and a positive 9 into here, either one of those possibilities, so if I plugged a negative 4 in for x for both or a 9 in for both of these, it would make a 0 in the denominator. And we said earlier that you're not allowed to divide by 0. We consider that an undefined value. So since that's undefined, what we're going to do is say that in this expression, x is not allowed to be equal to negative 4 or 9. Okay? We can see the 9 clearly. The 4 is still there, except that they ended up canceling. So again, in this case, these two expressions, this thing right here and my final answer over here, are always going to be the same, except when x is not equal, or excuse me, except when x is equal to negative 4, and when they're equal to 9, they would both be undefined. Okay, so this is just a little slide summarizing the steps that I just talked about. So first we said this is very important. You don't want to try to start canceling things right away when you have polynomials with plus and minus signs, different terms, and all that stuff. You want to factor the top and bottom completely unless you're dealing with only monomials. You want to look for greatest common factors, pull those out, and then cancel anything that's the same on the top and the bottom. And then finally, we noted any exclusions for the variable. Again, some classes may not make you do that, but it's not a bad habit to get into, because a lot of times you'll see that notation on the SATs, not asking you for it, but if you see it there, at least you're familiar with what it is. All right, so we're going to do 2 more of these. We've got 5w minus 10 over w squared plus 6w minus 16. So I'm going to start by taking a GCF of 5 out of the top. That gives me a w minus 2 right here. And then on the bottom, let's factor this into w and w. And it looks looks like in this case we'll need a plus and a minus. Remember that whenever that sign at the end here on a trinomial is minus, we need one of each sign, so it'd be a plus and a minus. And then we need factors of 16, one positive and one negative, that add to give me 6. And again, you can pause the video and try this here if you want. If you didn't pause it though, then we should be coming up with a plus 8 and a minus 2, because 8 minus 2 gives us 6. Finally here, if we look at these w minus 2's, these are going to cancel, and we're left with our simplified expression of 5 over w plus 8. And we're just going to take a second and state the exclusions. Again, what would give us zeros in the denominator and make this an expression that doesn't really make sense? So I'll let you, again, if you want to pause the video here and try that, you can. And if you did not, or if you did, w is not allowed to be negative 8 or positive 2. So again, these two expressions right here are always equivalent except at negative 8 and positive 2. Moving on to one more here. Okay, again, we're going to look for greatest common factors in the top and the bottom, and then factor. So on the top, it looks like I have a GCF here of 4. So this will give me an x squared minus 1 up top if I divide each of those by 4. On the bottom, I've got a GCF of 2, so I'll take a 2 out of everything in here. I'll divide each of these by 2, so that gives me x squared plus 5x minus 6. And now these insides will factor as well, so I'm going to leave my 4 and my 2 up here. I can do something with those, but I'll hold on for now. And it looks like actually both of these will factor. So x squared minus 1, again, if you know the shortcut, that helps. If not, just think of a 0x being in the middle, and you need factors of negative 1, one positive and one negative, that add to give you a 0 in the middle. And that should be just plus 1 and minus 1. That's a difference of 2 squares. Next up here on the bottom, we're going to need, again, one of each sign, 1 plus, 1 minus, because this last term here is a minus. If it was a plus, we would need, the same signs. And then, since, again, this is a minus 6, let's go with a minus, or a plus 6 and a minus 1. You might be tempted to do 3 and 2, but remember, that would only work if this were a minus, or excuse me, if they were both minus and this was a plus. So if this was a plus 6, 3 and 2 would work, but since it's a minus 6, we need different signs. So 6 minus 1 gives me 5. I'm almost there. We're going to go ahead and simplify as much as we can now. So the x minus 1s should cancel, and actually we can simplify 4 over 2 as well to be a 2 over 1. And now when I write down my final answer, I'm going to have 2 times x plus 1 over 1 times x plus 6 won't really change, so I'll just rewrite this as x plus 6. And there's one other possibility you might see on the keystones or on some sort of multiple choice test that you may take. This is a good answer. You may see this answer, but you could also see them potentially distributing this 2 back in to write this as 2x plus 2 over x plus 6. So you could see either one of these answers. You might see this one or you might see that one. Just be prepared for either one of those answers. We're going to finally state the exclusions here. So if we go back, we'll look at what could put zeros in the bottom. So both of these parentheses will be what I'm going to look at. A negative 6 and a positive 1 would be what x is not allowed to equal here. And then we have our final answer down here. Again, either one of these two is okay, and we also have the exclusions listed. So that's how you would simplify rational expressions. Again, what you're going to do is you can't skip this step. Don't try to just cancel individual terms in a polynomial. You've got to factor it first. Don't forget to look for GCFs. You want to cancel any factors that are the same in the top or the bottom, or any, if it's like a 4 over 2 like we had in the last problem, you can simplify that to 2 over 1. And then also, just be prepared to look for any exclusions as well. Anything that puts a 0 in the denominator is a problem.